Good morning, ladies and gentlemen, and welcome to the SAIEE Nuclear Chapter webinar on the 5G radiation effect on the human body. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. And by default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel. The QR code on the left-hand side of your screen which you can scan to subscribe to the SAIEE TV channel. And the recording of this webinar will be placed under the Nuclear Chapter playlist. A certificate of attendance will be issued a few weeks after this webinar once we've received the CPD validation number from EXA. Now, on today's topic, current scientific evidence indicates that 5G technology and the radio frequency electromagnetic fields it uses are unlikely to cause any health risks when exposure levels are within international guidelines. While some studies have investigated potential health effects, particularly at higher frequencies used in 5G, the main concern is localized heating, which is not sufficient to cause significant temperature changes in the body. Furthermore, most studies have found no evidence of adverse health effects and exposure levels below the recommended limit. Now, on this note, I'd like to introduce you to our presenter today, Dr. Rizamati Desmond Mavunda, holds a PhD in physics and MSc in medicine from the University of Witwatersrand, 2008 and 1996 respectively. He has significant experience as a senior scientist at Hillbrow, Baragwanath and Helen Joseph hospitals and has lectured on radiation physics at various tertiary institutions. He supervises MSc and PhD students and has served as an external reviewer for thesis and international journal articles. Welcome this morning, Dr. Mavunda. Over to you.
Thank you. Good morning, everyone. Today, I'm going to present the topic of 5G radiation effect on human body. The content is electromagnetic radiation, the type of electromagnetic radiation, mobile broadband service providers of 5G in South Africa, the type of device-to-device communication, progress in radiation frequency radiation for communication purposes, general changes in telecommunication, interaction of radiation with biological system, because this is the main area that I'm going to dwell on, public perception on radio frequency effects, measurements of 5G effects on public health, simulation of 5G radio frequency effects, then the radiobiological workflow, then my conclusion. Next slide. The objective of this topic will be to measure the radio frequency in decibels received from the source and determine the power density of the signal in watts per kilogram, to simulate the power density in decibels and watt per kilogram respectively by inputting the radio frequency to the code, measure the radio frequency effects, that is membrane permeability, nuclide changes from collected blood of the biological system. Compare the three techniques to provide a conclusion of the radio frequency effect to the biological system. Next slide. So here I'm just demonstrating what radio frequency, electromagnetic radiation is all about. If you look starting from the right to the left, you'll realize that they are showing here is the wavelength in meters, and on top there are the energy in electron volts. So now this little area that is visible a light that it's falling under electromagnetic radiation. So now, if you look at this area, that is where this 5G band is sitting, under the short wavelength there, which is this part of the spectrum. And the critical part of it is the electromagnetic radiation has got energy, and the energy is defined in terms of the Planck's constant multiplied by the frequency, which you can simplify also to say Planck's constant multiplied by the speed of light divided by the wavelength. So now, if you look at this equation itself, it gives us a very good idea as to if from moving from the right-hand side of the spectrum, which is there 10 to the power 4, if you take the wavelength and put it there under lambda there, you'll realize that the bigger the wavelength, the lower the energy. And the shorter the wavelength, the higher the energy. So meaning to say you can realize that the energy itself, it increases from the right towards the left, according to this equation that describes all this process that goes in there. Next slide. Now, in this discussion, we were looking at this 5G. 5G is nothing else, it's the generation of communication. So they classify it, there is the first generation, second generation, third, fourth, and I'm dealing with the 5G there. But now currently there's something that is going on in terms of research to look into the 6G. Next slide. So now, going back to the history itself, as you can see here, they are giving the years of this generation. You see the first generation there, advanced, it was dealing with advanced mobile phone services, total access communication system. That is the first G, which was introduced in 1986. So now going to the second generation, it was 1992. This one dealt with global system for mobile and digital advanced mobile phone services, that area. So now going to 2004, that's where now we have the 3G, where is the wideband code, division, multiple access. So here you could access quite a number of areas in communication. High-speed pocket access of your communication in terms of that. So now the next generation was the 4G, long-term evolution, LTE. That area, that's where most of the communication in the 2012 was happening. It was more dominated by this 4G. So then when we went to 2020, here, intelligence network, that is the 5G. So that area there, that is where we are sitting currently. We'll find that there are lots of areas that we can touch in terms of this. The 5G, the 6G also is still coming in 2030. Next slide. So now, from the electromagnetic spectrum, what I did was to compare the two areas to say the types of electromagnetic radiation. So I selected the ionizing radiation. This one, when you think in terms of the energy that I said, the shorter the wavelength, then you can calculate the energy. So now, any energy which is greater than 32 electron volt, this will cause ionization. Ionization is nothing else, it's complete removal of the electron from its orbiting shell. That it's one of the areas, and it has a short wavelength, as I described on the other side. So now, an example of that, you find X-rays, gamma radiation. Two types of ionizing radiation, because now we want to describe certain area, then you find the direct and indirect radiation effects. So this is well populated in terms of how the process deals with when it interacts with radiation. I'm talking about these X-rays and gamma when they interact with human tissue. So there are two classifications which we call it direct or indirect radiation effect. So now the big area that I'm talking about today is this one, non-ionizing radiation. The energy is equal or less than 32 electron volts. Example of non-ionizing radiation in this case are specifically went back to the generation of those communication. You can see 1G, 2G, 3G, 4G. The 5G, the energy range, when you look at the band itself, the energy itself is between 0.0024 electron volts to 0.4140 electron volts. As compared to this, can you see this? It's very high. So this level is quite low, of which it won't be able to cause ionization. That's why they call it non-ionizing radiation in this band. 5G vibrates the tissue, which increases the heat resulting in membrane permeability and nutrient changes. And this is where now when we look into how can this 5G affect the human body, it will be more to deal with generating heat that will cause membrane permeability and nutrient changes. Next slide, please. Now, when we look at mobile wireless communication, because that 5G deals with that, very high data rate and quality of services offers 1,000-fold rise in the total throughput, lower energy consumption, low latency, large coverage areas, efficiency spectrum sharing. Next slide, please. Now, if you look at the various technology to fulfill the 5G, you've got high density network with machine-to-machine in heterogeneous network. So you can have this by using this 5G. You can, the potential of this is this level, and it's a micrometer waves, massive MIMO, visualization of wireless resources. If you think in terms of fiber optics, that's what this it's dealt with. You can also transmit this a signal through the fiber optics. Visible light communication delivers high data rate, energy harvesting, cloud-based radio access network. That is how this can be utilized in this technology. Next slide, please. Now, when you look at the service providers for 5G in South Africa, you do have the SAIEE, the MTN, Ryan, Syntec, MWeb, and Vodacom. These are examples of those. So how this is operating, if you think in terms of that band of the 5G, what they do, they allocate a specific band in that range of the 5G to different service providers. It's like when you look into the radio station whereby you just change a number that is related to the bandwidth of that particular area. So that's how the same concept that is applied in communication, it does apply here in 5G in terms of communication. And according to the South African government, there are policies. Each service provider is allocated a certain band. So as you can be able to specifically check where do you get this band in relation to the energy itself that will affect the human beings. And in short, as you are sitting there, you'll find that you can be able to select which one is that when you do some area of coverage. Next slide, please. So now here, these are type of device to device communication, meaning to say, if you've got a cell phone and another cell phone or another device that is all what. So in terms of this device to device communication is split into in-band and out-band. Under the in-band, you've got undelayed communication, the other one overlay. Then on the out-band one, you've got the controlled and the autonomous device-to-device communication. Next slide. So now, here we are giving a typical example. This comes from the base station. If you look at this section, is the base station. You can receive the signal direct to the device or the cellular users. Like you can see all these different cellulars. So now from here, you can go to a device, then transmit it to another device or directly to there. And here, that's why device to device pair, that's similar to this device to device there, or vehicle to vehicle communication. And you can have a small cell communication. And this is how versatile this type of communication in 5G is method. Next slide, please. Next slide, please. Okay, here is another complex situation whereby you can see here I just indicated how versatile this 5G. If you look at internet, you can, from the internet, you can have the core, you can have the cloud, you can infrared communication to different type of system. As you can see here, you can even communicate to the airplane there. Those are satellites, through satellite global coverage. All this is based on this 5G. You can see all those areas, how you can communicate. The good thing about this is peak data rates. So you can see how fast it is. The latency, that amount, mobility, advanced data rate in 1 gig per bit, and also energy efficiency of less than 100, network densities, all of this. And you can see you can communicate from the satellite to the ship there, to the submarine, all those communication from substation to all those. That's how versatile this 5G is all about. Next slide, please. So now, if you look at the generation changes in telecommunication, here, the first one was analog. The second one is analog and text messages. The next one, the third generation, which was mobile, wireless internet. The fourth generation, cloud, mobile, broadband, high density. Then the fifth one, videos, ultra HD videos, and so on. So that's how you can look at it. Next slide, please. So now, interaction of radiation with biological system. You remember when I introduced the electromagnetic spectrum, I indicated this level. You can see you've got the radio waves there, the microwaves, of which now today we're talking about this, infrared, visible light, all of those. All of these type of electromagnetic radiation interact with the human body. And now, when you look at this electromagnetic absorption in human body, you can see now the yellow is less intense as you go up. Some they go to the hands. You can see the hands up here. You get a lot of radiation by different system that you are using. On this slide here, you can see is a family there, but they are being exposed to different sources of radio waves that are coming from different sources. So meaning to say you find yourself as a human being in a pool of these radio electromagnetic waves, being exposed to it on a daily basis. Because as you can see now, in terms of cell phone connectivity, radio, you name it, all of it, you get exposed to all this radiation. Next slide, please. Now, the public perception on radio frequency efficiency. So now there are quite a number of interesting stories. If you look at this, they say 5G is responsible for the increase of COVID infection. This is one of the issues that they will say. Radio frequency causes dizziness, and radio frequency exposure enhances carcinogenesis. Must fire probe emit 5G coronavirus claims. This was reported by the BBC News on April 4, 2020, that this fire was caused by the 5G. Those are types of perception that the public out there are always talking about, to say this might cause this, that, and that. Next slide, please. So now, how do we measure this 5G effect on the public health? So now we check the environmental 5G radio frequency measurement. This one is when you take your detector, radio frequency detector, you do your measurement, then you analyze the results based on that. Or you can simulate the radio frequency interaction with human. Then on top of that, you do the DNA or non-DNA related effect on individual exposed to 5G radiation. And this is today's area. It's more to deal with this section, whereby we are looking at the DNA or other element of the section of the human body. Next slide, please. So now, as you can see, this is another explanation. You find that you beam it out there. That's how the signal is sent out, all those communications. So it's worked out in terms of the equations we calculate and all those kind of things, how we can get the information. Next slide, please. Next slide, please. Okay. So to measure the radio frequency, we're using certain equipment like this equipment here. It has got the antenna there that receives the signal. So when it receives the signal, it's either it will receive it in this format or that form. So now through Fourier transformation, you get to that level. Then we get the signal like that. Then it gets split into this area. So the center one is the main one, because if you look at the antenna or the antenna itself, it has got the negative and the positive pole. So this is the image that these are the image. This is the real signal. So it reflects on that. So then you can see how the whole measurement comes in. Next slide, please. So now, taking that area whereby we are looking at the signal itself, this main peak, this main peak is represented by this part of the signal. And this one is represented by that small peak of signal there. and the other one on the right is this one. So this one is a 3D of this one, which is that peak, second, and next slide, please. Next slide. So this is how the equipment calculate, measure the density of the signal in decibels. So it uses this algorithm there, the calculations there. Next slide, please. So now these are a typical example of the measurement that you can get. You receive it in decibels. The equipment gives you these decibels, and then you move from this to the density to the density itself, which is given by W there, which is that. And the radio frequency station operate at a low wireless base of 5G. So this one is a typical example of, you remember I mentioned that the service provider is license given a certain frequency band. So this is one of the frequency band that was allocated to one of the service providers. So now when we do the measurement, we calculated and we get exactly the same signal that was licensed for that particular station. The measure SARS for the member of the public and the non-member of the public. So because this one are the measure of how far are you affected. It's measured in watts per kilogram. So for the member of the public, the limit is 0.08, whilst those who are working with those radio frequencies, 1.6 watts per kilogram, respectively. And this was according to the International Commission on Non-Ionizing Radiation Protection, which is that, and the International Electrical or Electronic in Engineering. Next slide, please. Next slide, please. So simulation. For us to be able to get to this level of measurement, we have to input the radio frequency of the 5G range to the code to determine, one, the power density in decibels, then the specific absorption rate, that is SARS in watts per kilogram. Because these are the indicators for us to say, are you being overexposed or not overexposed to this radio frequency? Next slide, please. So now, if you look, the last section now, it will be the radiobiological workflow. So now, blood sample collection, processing, then you've got this blood assay. There are two areas that we are focusing on. If you go to the, you must remember I said ionizing radiation. So for ionizing radiation, the focus will be on the white blood cell. So now, there they're looking at the chromosomal breakages or the micronuclide frequencies. That is how they check if someone is overexposed to this level of ionizing radiation. Whilst the non-ionizing radiation, here we are looking at the red cells, not focusing on the white cell. This side is the red cell for non-ionizing, non-DNA effects. So now the reactive, what are the indicators? Thus, it's the reactive oxygen species and membrane permeability. You remember I just mentioned earlier on. Also, we can also do the hemolysis or osmotic fragility. We check the fragility of the red blood cells. Next slide, please. So now, I'm just giving you the other side of ionizing radiation. You remember I said there are two areas in ionizing radiation, indirect effect of ionizing radiation. So a typical example, if you take a human system, it has got proteins, it has got fat, you've got water, you've got everything. So now when radiation interacts with all those structures in the cell, they cause ionization, which is a complete removal of an electron from its orbiting shell. So I took one as an example of water molecule. If you apply radiation to interact with this, it removes an electron. There is what ionization is all about. So this becomes that. So now this undergo dissociation. You get a radical plus this. This electron, which is that one, it combines with the neighboring electron, you form that. Also, it dissociates to form this and that. Then, if you take these two species, which is the OH species, you form hydrogen peroxide. So this hydrogen peroxide is the one that causes the cell to die. That's why we call it indirect effect of radiation, because the cell died not because of radiation, but because of this toxic substance which was created due to that radiation. Next slide, please. So now, when you look at the direct effect of radiation, here I gave an example here. You can see energy greater than 32 electron volts. So we have different types of radiation, alpha, beta, neutrons. Those are, we call it particulate radiation, though I didn't mention on the other side. But when we focus on the electromagnetic radiation, which is X-rays and gamma radiation. So now, when they interact with the chromosomes inside the cell, they cause a breakage of the chromosomes. If this chromosome stays stationary, it recovers, it becomes normal. So one of the other areas, if it moves, then you lose the fragments. Then you have this. And another probability is you find that there is a swapping of these fragments from the original side. You can see that side is negative, the other one has got plus plus, so they swap position. So all these two, then we have got another one. When you take this one, you join where it's broken, you get this part of the whole chromosome. So now we said this one is normal. The three are abnormal. The two, which are this one, that's how cancer is formed in terms of radiation. So now this one, when you get a lot of this, then you get cell death. That is a typical example what you get, skin burn. So now to monitor it, normally they take these white cells, they break the nucleus, then they add the dye. So where there's radiation damage, you'll see it will be glowing. So you can be able to identify, and we've got one lab in South Africa that does this. It's a Timber lab in the Western Cape. Next slide, please. So this slide, I was just giving a background information. So now, if you look at effect of non-ionizing radiation. So now, you remember I said for non-ionizing radiation, we're looking at the red cells. So what happened? It becomes elasticity and adhesion of the blood. So this become the structure changes. So you can be able to change depending on the permeability, how it is. And you can see that the size should be between 2 to 8 micrometers. And there, if it changes, you can see it changed to that. Another area that I need to specify is the mechanism of adhesion state of the platelets. So this is a normal platelet. So when you radiate it, then it becomes this and that and that. And form this one is, as you can see, the A, they say resting phase before damage to the blood vessels. This one. Shape of the activity platelet just after blood vessel injury. Then you have the platelet begins to spread out, initial thrombosis, meaning thrombosis is clotting of the blood. A full spread platelets, at this stage, aggregation of other platelets also began. Next slide, please. Okay, so now mechanism caused by disease of blood cells. So now post irradiation by this low radiation frequency. You look at the leukocyte. This is another type of white blood cells. Lymphocytic leukemia. Then the deformation is lower. Adhesion, no adhesion. Techniques or tools, they use this material. White blood cells, you get leukemia, low deformation and nothing else. Then optical tweezers, these are the techniques that we use. Lymphocytes is another type of the white cells. Mechanical stress. The deformity is very low, but the adhesion is high for this particular one. Red blood cells, hemolytic anemia. The deformation is very low, but no adhesion. White blood cells, lymphoma, and it has got lower adhesion. Red blood cells, sickle cells anemia, no deformation, you have high adhesion. Then also this one, the sickle cells, lower deformation, high adhesion to substances. Next slide, please. So now, these are some of the experiments which were done to test the 5G effect. The frequencies here, you can see frequency, the subject, what kind of substance they've used, exposure region. So if you look at the first one is prostate line cells. So they took the prostate cells, then they tested using a culture media, and the target, you look at that and the cancer of that one. So the energy itself, it was watts per square meter, it was that. So you look at all this, as you can see on the table. I won't go through all of this. So it's showing you that a lot of research has been done in human and in animals, depending on this, because of that element of saying, is this 5G going to affect human beings or living organisms? Next slide, please. So now, after I've explained all this information, the conclusion that we're making in terms of when someone gets exposed to 5G, the level of your exposure, what can be discussed is how long are you being exposed to this 5G? That is the first thing. The longer you stay next to this 5G, where there's high density of the signal, you may find that you are getting a signal coming from different sources. So that will be one of the contribution in terms of that. So what we do from the radiobiological side, we measure the specific absorption rate, which is SARS, of less than 0.08 watts per kilogram and 1.6 watts per kilogram exposure to the member of the public and non-ionizing radio frequency respectively. So this, we are guided by the International Commission on Radiation Protection and the Institute of Electrical and Electronic Engineering. Once you are within that range, then it means to say you won't be affected by this 5G. And Another thing that we can identify in terms of this, it will be what are the long-term effects. So that on its own, we need to be careful in terms of the actual measurement. So now, once you have done, as I indicated in my other slide, I said you measure, you do the measurements, then you simulate. So now your simulated results and the measured results, you compare them. Then you had to relate it to the effect itself, depending on the membrane permeability and the other stuff. So if you see that there is something, then that you can conclude. But from the research point of view, it seems that we don't have to be more to panic about this 5G, as long as we work within the framework of the guideline given by the international the commission, the International Commission on Non-Ionizing Radiation Protection. So that's all what I would say. Thank you.
Thank you, Dr. Mavunda. It's much appreciated. What a great presentation. Ladies and gentlemen, I encourage you to type your questions in the questions panel, which we're going to get to now. We have a few questions. Dr. Mavunda, our first question here is from Mariki Kombrink. She's asking, says, I have a question. So I tested cell phone base stations at a place in Kameeldrift. The owner said he had an employee. This employee never knew when the radio is being switched on or off. Every time this radio is being switched on, then this employee would complain of migraine, never knowing that the device is switched on, that is emitting the radio waves. I suppose she's asking, is this possible?
Yeah, these kind of comments, we always get them. But as I've explained, in terms of the radio frequency, the probability of a migraine is very remote. I wouldn't think that because of the vibration of that will cause that energy that will cause migraine. To me, it's something that I haven't. Even if we do the calculations, and I remember the kind of situation we experienced one whereby I was called to come and clarify. That was the time whereby they had this mast on top of the church, and there was a crash 500 meters from that, and 800 meters a secondary school. Then they were concerned to say, are they getting overexposure from this kind of system? So when we do the measurement, there was so little, as I indicated, when you look at the energy, because what is critically important is the energy. So in terms of radio frequency, the wavelength is too long. So when you take that wavelength, you calculate on that one, you automatically you realize that it won't cause that energy that will be higher than 0.0 watts per kilogram in that particular area for that particular radiation. And that is the guideline that is given by the International Commission on Non-Ionizing Radiation. So I would believe that that is not going to affect the person. Thank you.
Thank you, Dr. Mavunda. Our next question is from Walter Mwilwa. He says, is 5G different from Starlink technology? Could they both coexist in the near future, or one technology may prove superior over the other going forward?
Yeah, I would think that they'll coexist together in the future, but I don't think it's something that one should worry much in terms of if you have focus onto the electromagnetic spectrum, you can easily locate where different components of this is sitting, and you can work it out to realize that nothing will happen in terms of that.
Thank you. And our last question here. So if anybody has more questions for Dr. Mavunda, please type it now. Our last question here is from Offensi Noah. He says, I sense that you picked 5G because of the public perception it has. This is a good thing and great research. However, would it not have been useful to also compare other radio technologies that use frequencies similar to that of 5G? This could help give further clarification and radiation. With impact, what impact does the DSTV signal have with its Q-band radiation and any other radio access technology for that matter?
I thought I explained. If you go to the first slide, if maybe you can, if you've got time to go back to that slide for me, so as I can be able to clarify something here. The very first slide on electromagnetic spectrum.
This one.
Yeah, this one. Okay. You see the answer sheet here on this particular slide, as I explained, to say how do we now look at this 5G in relation to the other radiation. So if you check short waves, that's where now the radio frequency is sitting here. And if you go to television, there are the television sitting in this band. The radios are sitting there, the radar, it's sitting there. As you move from the long wavelength towards the short wavelength to your left, you can easily tell if this has got more effect as compared to that, or which one has got more effect. So as I indicated, the 5G is sitting there under this area there. And I even calculated to show that it's the energy within this 5G is very low in terms of electron volts. So that's how you can easily tell where is the problem. Because the more beyond that you go to X-rays, ultraviolet, X-rays, gamma, and cosmic radiation, that's where a serious effect is sitting. Not this side from the radio frequency TV 5G, because of the energy. Because what tells us if there is a lot of effect is this electron volt, the energy itself of that particular wavelength. And secondly, it will be the intensity of how close are you to the base station, whereby you'll get more vibration, of which most of us, we don't sit next to that. Is by the time it reaches us, it has reduced by the square of the distance from where it originally started. So that is how I can, one can look at it and say, how do I tell whether 5G is more dangerous as compared to this, the radio, TV? So obviously, even the television, you need to have a certain distance in terms of some of, more especially the old television, whereby you induce some electrons. So that will affect your eyes or your hands. I don't know if the question has been clarified in terms of this, because that's what the whole issue sits here on this electromagnetic radiation spectrum.
Thank you, Dr. Mavunda. Now, our next question is from Jamil Sahed. He's referring to slide number 18. I just want to find it here. Yeah, this is it. He's asking, let me just enlarge it so everybody can see. He says, the human body image overlaid with a color gradient shown in slide 18 How was this obtained? Was it calculated or was it estimated using measurements from simulated tissue and probes?
Yeah, this was simulated. It was simulated in terms of to be able to relate, to say, if in the first place you measure the activity there and there and there, say how are you affected? And one of the things, they didn't put the desk here. You're sitting in front of your laptop, and the laptop is sitting on top of the table. So now your body, the torso on top is closer to the television. That's how this radiation seems to be. And also depending on the type of the system that you are using. So, but it's more simulated pictures, this one.
Thank you, Dr. Mavunda. Now, ladies and gentlemen, this has come now to our last, it was our last question. I thank you very much. Before we go, you just look in the handout section, you'll find the April issue of the What Now magazine, which you can download in PDF format. I'll give you a few seconds for that. In the meantime, I just want to thank Dr. Mavunda. Thank you so much for your time for presenting this very informative webinar. And ladies and gentlemen, please visit the SAIEE website for our upcoming webinars. We've got quite a few line up in May, but I would like to take this opportunity then to wish you all a blessed Easter weekend. And I hope that if you travel safely, and we will love to entertain you soon again in May. Thank you. Have a lovely day further. Bye.
Bye-bye.